Hello, everyone. Warm welcome to each one of you. Today, we are diving into numbers system, especially integers, rational numbers, and irrational numbers. Get ready. Today, we are going to explore some rational minds to some irrational rebels. Yes, let's explore together. You might be surprised. Where do you see them in real life? Excited? Yes. So, number system, let's begin with this big picture. Number system is like a family. It has different members. Natural numbers and whole numbers we have done yesterday. Now it's time to understand integers, rational numbers, irrational numbers, and all these sets get included in real numbers. So our first thing is integers. Yes, in our recipe, the first ingredient is our integers. It includes negative numbers, positive numbers, and zero. So what did you understand by integers? Adding negative numbers to whole numbers? Yes. So examples are here -5. Yes, it does include negative numbers too. Zero is included. Positive numbers are included. Exciting. So integers are nothing but the negatives of whole numbers. Have you ever noticed in some buildings, elevators start from basement? That is your -1. Ground floor? That is your zero floor. And keep on going by positive floors, 1, 2, 3, and so on. So, and where do you see the integers in other examples? Have you noticed temperatures? -5 degrees Celsius. Sea level -430 meter, isn't it? These all are integers connected to our real life. Okay, it's time to have a tasty question. Have you eaten 3 out of 8 slices in a pizza? Yes. So your fraction will be 3 by 8. So what is a fraction? Fraction means part of a whole. Yes, whole as a quantity. Let's suppose you are having a pizza, a whole pizza. It is having 8 slices. Yes, if you take 1 out of 8 slices, you are having 1 by 8 as fraction. If you are having 2 slices, you are having 2 by 8 as a fraction. 3 by 8 as a fraction. Keep on going like 4 by 8. 5 by 8, 6 by 8, 7 by 8, and lastly 8 by 8. That gives you 1, a whole quantity. So basically the fractional numbers are whenever you are having a quantity and you are having parts of it. Yes? So let's suppose you call for a 1.5 cups in a recipe. That's your fraction, and your recipe is taken as a quantity. So rational numbers. Now let's jump up to the rational numbers. You have understood the fractional numbers. These are somewhere related to fractional numbers. Fractional numbers are parts of whole, having numerators, having denominators. Yes, 3 by 8, previous example, 3 is taken as numerator, 8 is taken as denominator. Same way, a rational number is any number that can be written in the form of P by Q. What is P by Q? P is your numerator, Q is your denominator. So it is written in a fractional form, but with a condition. What is the condition? That Q should never be 0. That means your denominator should never be 0. That is the difference between fractional numbers and rational numbers. Okay. Let me just ask you one question. Fractional numbers can be negative. What do you think about it? Yes? Yes or no? No, ma'am. Fractional numbers cannot be negative numbers. Why? Because fractional numbers means having parts of something exists as quantity. If it doesn't have any quantity, how can we take parts of it? So they cannot be afforded in negatives. But rational numbers can be negatives. Because I have told you the only condition is denominator should not be 0. Please note down this definition. A rational number is any number that can be written in the form of p by q like fractional numbers, but along with the condition q should never be 0 and p and q are integers, means they can be negatives. Yes, please write down it. Done? Very good. So a question is here. Let's think deeper. Is 0 a rational number? What do you think? Recall the definition of rational number. That denominator should not be 0. Can I write it in the form of p by q? Zero can be written like that? Yes. The condition is denominator should not be 0. There is no condition on numerator. Numerator can be 0. So yes, 0 is a rational number. It can be expressed as p by q form. So your answer is yes. Now, what are the key characteristics of rational numbers? It can be positive, it can be negative, it can be 0. Yes. And the set includes whole numbers. Yes. Whole numbers are there, 0 is there, and every positive number is there. Fractions are there. Yes, 3 by 4. Just remember the condition. Denominator should not be 0. And decimals. Talking about decimals. Yes, we'll talk about decimals in detail. Rational numbers are based on decimals too. We have done the part of fractions. Yes, rational numbers are dependent on fractions too and dependent on decimals too. Let's zoom in into decimals. So these are the differences. First of all, just note these differences between fractional numbers and rational numbers for much clarity. Then we will jump into the slide of decimal ones. So rational numbers, p by q form, q should not be equal to 0, can be positive, negative, 0, and examples are there. Yes, you just write the examples of decimals. I'll teach you. And fractional numbers are form p by q, same thing, but always positive because we are taking parts of a quantity. If quantity is there, then only parts are taken. If quantity is not there, no negative thing can be imagined. So shows part of a whole, yes. Examples are 3 by 5, 7 by 4. Just take a note of it and let's move further. The main difference is fractions cannot be negative, but rationals can be negative. Yes, dear children, let's move ahead. Let's take the real life examples. Sharing cake. Yes, cake is there, a quantity is there. So we are taking parts of it. Out of 4 slices, I'm taking 3 slices. Yes, so slice in fractions, kind of fractional number, and further rational number because condition is satisfied. Q is not our 0. Here shopping, decimals are there. Yes. Can you just write the decimals into fractional forms too? Yes, we can write. So after simplifying the decimal form, 5 by 2 I'm getting. That is also a fractional number. And talking about time, 1.5 hours, 15 by 10, after converting it into fractions and after simplifying it to its utmost form, 3 by 2 I'm getting. That is also fractional hours. Yes. So it's pretty much clear about what fractional numbers are, what rational numbers are based on the fractions, based on the P by Q forms. Finally, let's zoom in into the decimal ones. So terminating decimals. What do you understand by the term terminating decimals? Terminating means ending somewhere. It does have an end. It should be ended after finite number of digits. Yes, a terminating decimal is a decimal number that knows where to stop. That knows where to stop. It is ending ever. So price tag decimals I'm taking, it is getting ended after 2 digits, isn't it? So yes, it could be converted into a fractional form that lead to further rational form. Recipe 1.25 cups can be converted into fractional form, further rational form. Measurement 2.5 meter means it is ending after 1 digit. Yes, they do have a stop. They end somewhere. So that is your terminating decimals. The decimals. What if the decimals never ends? What do you call them? Non-terminating ones. Terminating ones are those know when to stop. Yes, opposite of that, non-terminating decimals are, they don't have an end. They are never ending. Yes, so based on non-terminating decimals, we still have rational numbers, but with a twist. What is the twist over here? See, the decimals that are never going to end. What are the examples of those? I just want you to get your notebook and divide 10 by 3. I'm just giving you 10 seconds for that. Just divide 10 by 3. What pattern are you observing? What answer you are getting here? Just divide 10 by 3. 3 threes are 9. 1 is left as remainder. Then put the decimal. Bring 1 0. Again 3 threes are 9. 1 is left. Bring 1 more 0. 3 threes are 9. Keeps on going like that. What is the answer are you expecting here? 3.333333333 keeps on going. It is never ending, my number explorers. Yes, it is never ending. That is the best example of non-terminating decimals. But the main thing is here, it does have a pattern. What is the pattern? That 3 is getting repeated, ma'am. We only know that 3 is getting repeated, but we don't know up to where. Yes, but a pattern is there, even if it is non-terminating, but if it is repeating, if it is having a pattern, then also it is counted as a rational number. Yes, just write terminating means surely rational. Non-terminating means we have to see whether it is getting repeated or not. R for repeated, R for rational. Non-terminating but repeating gives you rational. Call out with me. If it ends or repeats, rational. If it ends or repeats, rational. Yes, say it with me. If it ends or repeats, rational. Clear? So these are many examples you can see here also. 1.42857. Again, 1.42857. This number is getting repeated again and again. Yes, a pattern is there. Repeating digits are there. So it is counted in rational numbers, even if it is never ending. But we have an idea. We can guess it that this number is getting repeated. So that would be counted your rational numbers. If it repeats, it's predictable at some point and therefore rational. If it ends or repeats, rational. Now, The decimal never ends because it is non-terminating, also doesn't get repeated. We have no idea about these kind of numbers. Non-repeating, not having any pattern, non-repeating too. Non-terminating, non-repeating, non-terminating, non-repeating. So that would be what? That has a special name. The wild one. Irrational numbers. Yes? If it ends or repeats, rational. If it does not end, does not repeat, it is your irrational number. So coming to its definition, irrational numbers are numbers just opposite to the rational numbers. So the definition would be that cannot be written in the form of P by Q. Yes, where P and Q are integers. Integers means negative signs are also included. And Q, the condition, denominator should never be 0. These cannot be written in fractions at all. They are non-terminating and non-repeating decimals. Please write this definition. Non-terminating, non-repeating, and just the opposite of rational numbers. Cannot be expressible as P by Q form. Once you just remember the definition of rational numbers, you would be automatically revising the definition of irrational numbers. They are correlated. Just note it down. Written? Very nice. We can swipe it now. So what key points we have observed here? I have used many terms. Repeating, non-repeating, terminating, non-terminating. Yes. So non-terminating means terminate itself means an end. Non-terminating means doesn't have any end, keeps on going. Non-repeating keeps on going without any pattern, without any guesses. So no fixed pattern they follow and no ending point is there. Cannot be converted to exact fractions. These are the key points of irrational numbers. Please note it down too. This will help you remember what irrational numbers are, and you can directly pick them just by looking at them. Noted? Very good. So famous examples are there. Pi. Pi is an interesting example. Yes, while finding circumference, you use it 2 pi r. That pi. Many mathematicians have spent their life after finding its value, but it never ended. Pi does not have any end. It keeps on going without any pattern. That's why it is counted as a rational number. But where we use it? In circles. Wheel is itself a circle. And under root 2, the root ones. Some of the root ones are also taken as irrational numbers because after finding their roots, these dot, 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 dot are for non-terminating. Means keep on going. We don't have any end. Keep on going. So diagonals in squares, let's suppose you have a square of 1 unit and the diagonal will be hypotenuse of that. So what it would be? 1 square plus 1 square under root, that would be your under root 2. Yes, so that is also an irrational number. Similarly, under root 3 cannot be predicted. Its value is also keep on going without any pattern. So root 3 is also taken as irrational number and Euler's number. Whenever you are studying higher maths, you will be familiar with these terms. Okay, so these are the famous examples of irrational numbers. Now let's think critically. Can a number be both rational and irrational? Why or why not? What do you think? What do you think? Both cases are possible. How it could be possible, my dear students? Even if it is expressible as P by Q form, it could be taken as fractional number, rational number. And if it is not expressible as P by Q form, it cannot be taken as a rational number. It would be definitely an irrational number. So there is no such number that is rational and irrational both. Few examples are there. I'm giving you some decimals right now. So 0.25, if it ends, it is ending after 2 digits. If it ends, definitely rational. If it ends or repeats, yes, if it ends, it is ending. If it does not end, but it is repeating, same digit repeats, rational. Remember the rule, if it ends or repeats, it would be rational. And this number is not following any pattern. 1.4, 1, 4, 2, 1, 3, keep on going. Random digits are coming. We don't have any guesses about it. So it would be taken in the category of irrational numbers. No pattern, irrational. So call out with me. Non-terminating, non-repeating, no pattern, irrational. Non-terminating, non-repeating, no pattern, irrational. Non-terminating, non-repeating, no pattern, irrational. Can you give me 3 decimals? And others must identify, maybe your classmate, maybe your best friend, which is rational or irrational? Yes. You can write 3 decimals. Just write it now. Any 3 decimals. It can be ended. It cannot be ended. But if it does not end anywhere, 2 cases are further. If it would repeat or if it would not repeat, based on these categories, write 3 decimals and your partner will guess it. Take it easy peasy once. 0.25, ending, rational. 0.33333, not ending, but repeating, rational. Under root 2 pi, irrational. I helped you? Thank me later. Yes? So comparison, let's compare them just for concept clarity. Can be written as P by Q form. It would be what? It would be rational. It cannot be taken as an in P by Q form. It could not be taken as irrational. Decimal type would be what? Based on the decimals, terminating is there. It should be repeating. R for repeating, R for rational. It would be categorized as rational. If it is non-terminating, simply choose the irrational one. And its examples are fractional forms. 3 by 4 minus 1 can be written in a fractional form. Yes, minus 5 by 1. Again, 0.6, it is ending somewhere. Yes, it is ending after 1 digit, can be taken as a rational number. Under root 2 and pi are the famous examples of irrational numbers. Let's just answer this question. If pi is irrational, I have told you that pi is irrational. Why do we often use 3.14 or 22 by 7 in calculations? What are we sacrificing? Did you get my question? We have 2 types of pi's value. One is 22 by 7. One is 3.14. 22 by 7. Is it a rational number? Yes, ma'am, it is a rational number because it can be written in a P by Q form, fractional form. But it's a contradiction. I have just told you that pi is taken as irrational numbers. Many mathematicians could not find its value. It never ended. It's contradiction. So what is the answer? Just write it. It's a statement that 22 by 7 is not the exact value of pi. It is approximate value of pi. Yes, for the sake of convenience in some problems, we use this approximation. It is not our pi. It is somewhere nearby our pi. Yes, understood? This is the most important question. Pi is always an irrational number. Somebody asks you, 22 by 7 is rational? Yes, it is rational because it is not pi. It is approximate value. Just note it down. 22 by 7 is approximation, approximate value. But exact value of pi is irrational. 3.14, keep on going. Noted? 22 by 7 is an approximation of pi, not exact pi. Let's recap. A bigger set is real numbers. Real numbers having its subparts. Natural numbers we have done. Whole numbers we have done. Rational numbers we have done. Irrational numbers we have done. Somehow I related it to fractional numbers too. Yes. So these are under real numbers. All integers are rational. Yes. All integers means negative, positive, zeros can be written in a p by q form. Yes. Just find their fractions. Just find 1 as denominator, you can easily find them. Not all decimals are rational. Which one decimals are not rational? Non-terminating but not repeating ones are irrational numbers. Rational is p by q. Irrational is not equal to p by q. It cannot be expressed as p by q. Just note it down. Just note it down. I hope everything is clear, my dear students. So that's all for today. That was the concept that you have understood, that you have dived into number system. Yes. Now you can take a pause, you can drink water, you can take some rest. Then we will do our activity part. We will put it into an action. Whatever we have learned, we will put it into an action. We'll do some exciting activities. Okay, just have some water, then we will start. Get ready. Let's do some activity. Excited? Me too. So let's put math in real life. I always say you must remember maths one-liner. Yes, that's maths is not just found in maths textbooks. It is something that we deal every single day. Are you ready? Just relate real numbers, rational numbers, irrational numbers to our day-to-day life. Yes, it would be exciting. You can directly pick what is rational, what is irrational by just looking at them. So board game scores. When you just don't play well, your score, when you lose points, your score goes down. Negative ones, integers are taken, and your score must be zero just when you start the game, and your score keeps on increasing as you go. So positive 3, positive 5, positive 100. Yes, these are the examples of integers too. But it can be expressed as p by q form. It can be taken as a numerator and denominator form. That can be taken as further rational numbers too. And if you call for 1.5 cup of sugar while making something, while baking a recipe, yes, so that would be considered as rational number. Elevator floors, I have given you that example. Basement ones are taken as negative ones, floor 0 and positive floors are taken as positive ones. So everything is in combined form, gives you a fractional form too. Yes, just make that fraction by putting 1 into the denominator. These are also rationals too, integers too. And rationals are fractional form. Yes, these are used in our day-to-day life. We have to measure something. Yes, we have to measure something and we are putting it into an action. And talking about irrational numbers, pi, under root 2, we have to study maths too. Yes. So in order to find the value of diagonal of a square of 1 unit, you must be getting under root 2. Yes. Your tiles, square tiles. Yes, your floor tiles are the best example of irrational numbers. And exponential growth in finance. Yes, growth is most important. Yes, you will be understanding these terminologies in your further higher maths. Let's just do one case study. An engineer told me the wheel's radius is under root 2 meter. Let's make it. I asked, can we express it as a fraction? Can we express it as a fraction? Under root 2 is what? Its value is. Keeps on going like that. What is the formula? What is the statement I have told you? Non-terminating, non-repeating, no pattern gives you irrational one. So under root 2 cannot be further expressed as P by Q form. That is obvious now. So I'm just putting these examples over here just to make you clarify, because these things are used in our day-to-day lives. We are talking about squares, diagonals, we are talking about circles, we are talking about pi as circumference, because we deal with them in day-to-day life. Without maths, this world cannot exist. Numbers without numbers. Yes? So these are vital concepts in bigger foundation of maths. The myth buster time. Yes, irrational numbers. Looks a powerful name. It seems that irrational numbers are found rare. Yes, just by talking about their names, wild one name. It's it's like they cannot be found as much as rational numbers are. So myth is irrational numbers are rare, but the truth is, but the fact is, in a number line in between two rational numbers, how many dots can you put? Just draw a number line and let me know how many dots can you put. If you are drawing a number line, let's suppose between 1 and 2, put the dots that you can put, as many. How many dots can you put? Infinite, ma'am. Infinite dots I can put. So same way, infinite irrational numbers can be found. When you zoom it into this 1 and 2 number, there are many irrational numbers found. So that was a myth that irrational numbers are rare. So between every two rational numbers, there are infinite irrationals. Would you remember for life? Yes. Now let's be number detective. Are you ready? Sounds interesting, yes? I'll give you some of the decimals and you have to just find whether it is terminating, whether it is non-terminating, whether it is rational, whether it is irrational. Yes, it might be easy for you right now. Decimal nature of 0.25. What it would be? Does it stop? Tell me, does it stop? Yes, it does. It is getting stopped after 2 digits. So that would be taken as rational numbers. Easy. Next one. What is the nature of 1.33333? What these dots are indicating? That it keeps on going. So what it would be? Yes, non-terminating, very good. But are you finding a pattern? Are you finding a pattern? Yes, ma'am, 3 is getting repeated here. So it would be counted as rational. If it ends or even repeats, it would be taken as rational. Decimal representation of under root 2. You must remember the value of under root 2, 1.414 dot 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 dot. Keeps on going. Non-terminating, non-repeating. That means what? Irrational. Very good. We cannot express it as a fraction. Non-terminating, non-repeating, no pattern. Hence, irrational one. Decimal representation of this big number, giant number. Just look at it. 0.101, 101, 110, then 4 times 1 and 0 keeps on going. Does it have any pattern? No. A random set of digits is coming again and again. So no pattern is followed. That means irrational numbers is this. Let's just tell me whether it is true or false. Every decimal number is rational. Every decimal number is rational. Think deeper. No, it's not like that. Every decimal is not rational. Which one is not rational? Ma'am, non-terminating ones are not rational. Yes, so it was false. Under root 2 is irrational. Sounds simple? That under root 2 was irrational, so under root 4 was irrational. No, but under root 4 is your 2. 2's square is 4. So under root 4 is giving you 2. So 2 is your rational number. It can be expressed in P by Q form just by putting 1 into the denominator. So it is not irrational, ma'am. It is rational. That one also falls. Pi is 22 by 7. Yes, it's obvious now. Pi is not 20. Pi is not 22 by 7. It is the approximate value. So pi is irrational. So interested? That was it. So I hope you enjoyed this session with such brainstorming questions too. You have become number detectives, isn't it? So keep on counting, keep on finding rationals and irrationals. Thank you so much for today.